During the 21st century, human beings have done great wonders. Today, we are going to introduce one of them, that is, how we took a picture of the black hole. Our slides can be divided into 4 parts. First, introduction, second, theory, third, basic ideas, and the last one, that is method to improve. Einstein has predicted the existence of black hole in his theory of gravity. But before we took a picture of the black hole, no one has discovered the black hole face to face. However, on April 10, 2017, actual physicists announced that they had captured the first ever image of the black hole. That is, the world's first got visual confirmation that the black hole really exists. This is the picture of the black hole M87, which is 55 light years away from us. Before going to the straight point, let's introduce 2 theories. The first one is the longer the wavelength, the stronger the ability of the wave to travel around obstacles it will be. That is differentiation. So we can use them to take photos of the black hole. And the second is angular resolution. The smallest size of the object we can see equals to lambda over b. So to decrease the smallest size we could see, there are 2 methods. That is, observe waves with shorter wavelengths or use telescope with greater size. First, describe how difficult it is to observe a black hole in the center of our galaxies. That is, the difficulty level is approximately seeing an orange on our moon from the Earth. So, why using wave with shorter wavelengths cannot be practical? Of course, there is disadvantages and advantages. First, the advantage is that there are abundantly amplitude electromagnetic waves released by the black hole, like gamma waves and cosmic waves, whose wavelengths which infinitely approaches to zero. But the disadvantage is that, due to the differentiation of the waves, that magnetic waves with shorter wavelengths can be easily distracted and easily die down in the process of transforming. So, the shorter wavelengths we get on Earth released by the black hole is maybe 0.0001% than it originally used to be. So that will be meaningless. And therefore, however, there are a lot of noise in the universe. So with such weak signal, we can't directly judge that which is noise and which is the signal we want for the black hole. So the method we exactly used was that the Event Horizon Telescope, which is called EST, that is a planet scale array of 8 ground-based radio telescopes through international cooperation. The basic principle of the observation is that take 2 telescopes on Earth as an example. They separated by some distance and observe a same object at the same time, and they collect data. Electromagnetic waves come from the black hole as a wavefront. The 2 telescopes will catch a slightly different part of each wavefront due to the separation of each part. And then they analyze the delay for the slight difference between the wavelengths they receive, and by doing so, they can measure the black hole structure after analyzing. Of course, there will be some improvement. The first improvement is, next time if we are still observing some stars or black hole-like star systems, we can use more telescope or by longer time of observation. Consider the Earth is rotating, like one telescope after rotating can become a straight line, that is, an array of telescopes. And the straight line after we apply more telescope then can finally form a plane. That is, we eventually can get the effect we want, that is, a telescope that is as big as the whole planet by using more telescope and longer time of observation. And the second improvement is we can use more accurate and rigorous model of image perception. That is to say, we cannot simply based on Einstein's theory. Originally, there are 1,000 pictures taken from the black hole. And what if Einstein's theories are wrong? If we keep on focusing Einstein's theory, we can only get what we want to get, but maybe perhaps not exactly what it is exactly to be in the center of our universe. What if in the center of our universe is not a black hole? Things will happen if we apply more accurate and rigorous models of image selection. Thus, we can get one step closer to the truth and fact. So this is the end. Thank you for listening.